What is the mass of 5 moles oxygen gas? We first write down our question in an equation form. What is the mass is how many grams. So we're going to measure mass in the unit grams. So that's why we write how many grams is what is the mass of 5 mole of oxygen gas. Oxygen gas is O2, not just O. And it's not just O2, it's moles of O2. So we need to multiply this by a conversion factor which has moles of O2 at the bottom to cancel out the given unit and grams at the top to introduce the required unit. Now we know from the periodic table that the molar mass of O2, oxygen, is 2 times 16 grams per mole, which is 32 grams per mole. Each mole of oxygen atom has a mass of 16 grams, and there are 2 moles of oxygen atoms in every 1 mole of O2 molecules. So that's why we must multiply 16 by 2, 32 grams per mole. So 1 mole of O2 has a mass of 32 grams. So here we have equivalent values, top and bottom. They both refer to a mole of oxygen. The top is the mass of that mole of oxygen, and the bottom is just plain referring to the mole of the oxygen. Oxygen gas, that is, O2, not oxygen atoms O, because we are asked oxygen gas. 5 times 32 is equal to 160 grams. What is the mass of 2,9 moles carbon dioxide gas? Try this yourself before I show you the answer. What is the mass? How many grams is or of 2,9 mole CO2? We multiply this by a conversion factor which has mole carbon dioxide at the bottom to get rid of the old unit, grams at the top to introduce the required unit. Both top and bottom must refer to the same thing. We know from the periodic table that the molar mass of carbon dioxide CO2 is 12 grams per mole for the carbon plus 2 times 16 grams per mole for the O2, the oxygen, and that gives us 44 grams per mole, meaning that 1 mole of carbon dioxide has a mass of 44 grams. 2,9 multiplied by 44 is equal to 127,6 grams. What is the mass of 4 moles of CH3COOH? Pause until you've done this yourself. How many grams is 4 mole CH3COOH? We multiply by a conversion factor which has moles CH3COOH at the bottom to cancel that unit out, and grams at the top. From the periodic table we know that the molar mass is 2 times 12 for the 2 carbons plus 4 times 1 for the 3 there and 1 for hydrogens plus 2 times 16 for those 2 O's. 24 plus 4 plus 32 equals 60 grams per mole. That is the molar mass, meaning that 1 mole of this compound has a mass of 60 grams. 4 times 60 is equal to 240 grams. How many moles of sodium carbonate have a mass of 48 grams? Try this yourself first. How many mole of sodium carbonate have a mass of 48 grams? Our unit factor must have grams at the bottom, mole sodium carbonate at the top. We know that the molar mass of sodium carbonate is 2 times 23 plus 12 plus 3 times 16. 46 plus 12 plus 3 times 16, 106 grams per mole. 106 grams is the mass of 1 mole of sodium carbonate. Grams cancel, we're left with moles sodium carbonate. 48 divided by 106, 0,45 moles of sodium carbonate. How many moles of calcium hydroxide have a mass of 72,5 grams? First do this yourself before I show you the answer. How many mole calcium hydroxide have a mass of 72,5 grams. We multiply that by a unit factor with grams at the bottom and moles of calcium hydroxide at the top. The molar mass of calcium hydroxide is 40 for the calcium there, plus 2 times 16 for the oxygen, plus 2 times 1 for the hydrogen, which is 74 grams per mole. 1 mole of calcium hydroxide has a mass of 74 grams. 72.5 divided by 74 is equal to 0,9797, which we round off to 0,98 moles of calcium hydroxide. Try this yourself before I show you the answer. What is the mass? How many grams of 7,3 times 10 to the power 22 iron atoms? I can just write Fe because that means iron atoms. My unit factor must have iron atoms at the bottom. Notice it's not moles of iron atoms, it's iron atoms. And grams at the top. Now remember that this number here, 55,8, it is the mass in armor of 1 atom. So if I was using the unit armor, then I could use that for 1 atom of iron. And maybe I should work that one out as well. It doesn't actually tell me that the mass must be in grams. I just assumed that. If it had said the mass must be in armor, well, this would have been the right conversion factor to use. This number also means 55,8 grams for a mole of atoms. And a mole of atoms is the same thing as 6,02 times 10 to the power 23 atoms. Mole and this number are synonyms. So 55,8 grams is equivalent to 6,02 times 10 to the power 23 iron atoms. 7.3 exp, or times 10 to the power 22, multiplied by 55.8 divided by 6.02 exp 23 is equal to 6,766, which we round off to 6,77 grams. Now let's change that. Let's interpret this question, instead of being what is the mass in grams, to rather be what is the mass in atomic mass units. How many armor is 7,3 times 10 to the power 22 iron atoms? So now we're going to use this unit conversion over here. 1 iron atom has a mass of 55,8 atomic mass units. 7,3 exp 22 multiplied by 55,8 is equal to 4,07 times 10 to the power 24 atomic mass units. And this mass here is the same mass as this mass. 6,77 grams is 4,02 times 10 to the power 24 armor. They're just written in different ways. One's in grams, one's in armor, but that's the same quantity of substance. It's the same mass. And you can see if you divide this number here by Avogadro's number, 6.02 times 10 to the power 23, then you get this number 6,77, because the conversion between armor and grams is Avogadro's number.